I guess the real point I'm trying to make is there's a job to be done in helping the kids to understand the maths question. And the way you might do it is you might have it projected on your smart board and have a kid come up and say, you know, which of the bits of information are important, put a circle around them. And so that they can really realise you don't actually have to follow the whole sentence. Some of the bits are just padding. And so to try and come to understand that. What I'm really emphasising is that generally maths teachers don't do that stuff. They just have their fingers crossed and hope the kids can read it. But there is a job to be done to do that. Okay, all right. By the way, I actually think that's a really good thing for kids to do. I think it's a good thing for teachers to do. And do you agree that that was an interesting, like, teacher learning session you could run? Because, by the way, you could actually then now put up the scores for your kids. See, it's only question 28. Only 28 is a Year 7 question. You know, question 30 is probably a grade 3 question. We don't have fractions as unequal parts of a shape or so. See, question 10, there's a quarter of the kids in the state who can't do question 10. 4 times something equals 8 times 3. Now, that's really a grade 4 question or something. It probably is on the grade 3 NAP plan, for all I know. It probably is on the grade 3 NAP plan to do that. You know, what fraction has the same value of 2 3/4? Well, they do in that grade 5. That's probably on the grade 5 NAP plan. What was that one? So 64% got that right. So trying to get a handle on... Now, what you'll find is your schools will actually vary from that quite a lot. Yeah, it'll be sort of like you can expect that the kids will be like either 10% higher or 10% lower, but it actually tells you something. It tells you something about your kids. So I actually think it's a good thing to do for teachers. I actually think it's a good thing to do for kids. That's why I was sort of so keen to show you that there is actually something there that we can use as teacher learning. But what I'm going to do now is I want to talk about the idea of templates. In fact, I don't think I've actually gone back enough. What this would be, what I'm going to talk about, is for those people who say the way we're going to work together is by studying our teaching and learning from the teaching. And we might actually do the Japanese lesson study thing, which I think you've probably heard about. I'll explain. The work of teachers is lessons, and teachers like to talk about lessons. So lessons can be used as the basis of teacher learning. Lessons are sometimes treated as non-problematic, but they're complex. Okay, now I think you've seen this before. I'm just reminding people that there's a process that you can do where 2 people do lesson study. The point about this process, by the way, that's different from just someone coming in to observe you, is that what it does is it changes the focus from the teacher to the lesson. So the idea was a group of teachers, now that might be just 2, teachers plans a lesson, one person teaches and the others watch. And then you revise the plan and then the other person teaches it. And then you talk about it again. Now if there were 3, you might get 3 people to do it. But the idea is people work on a plan and then teach it, and it's learning by studying the lesson. And so it's just a process. What I actually suggest is that either with that or by itself, it's also important to think about the structure of lessons. Now Sue was talking about having a numeracy warm-up drill, and by the way, I think you should do that in just about every lesson anyway. But Sue was talking about launch, explore, summarise, to review. Now, I'm actually going to talk about a more complex structure than that, because I think that doesn't... I actually say that there are 4 different types of maths lessons that you teach, and you should teach them at different stages of the week. And we actually had a bit of a talk about those people who've got like 100-minute lessons. Now, my view is that you should teach a whole lot of different lessons in there. And you might even do in the 100 minutes, you might even do 2 or 3 of these lesson types, so the kids are having a different experience. By the way, you don't have to make it as complicated as this, But there are some people who've done this sort of stuff, and so the subtlety of the different parts will make a difference. Okay. It's a way of providing advice on lesson structures to prospective and experienced teachers. And there are two advantages. The templates can support teachers in creating lessons, and the templates provide guidelines for the pedagogical guidelines, and they're adaptable, so you can use them over and over again. I'm going to talk about 4 lessons, all on the topic of fractions. They're going to be different lessons to do that. I'm just going to show you what I mean by there, and we won't do them all today, but we'll do some of them. Okay, why would I choose fractions? I think I mentioned before that, in fact, to me, the only difficulty that students are likely to experience in calculus and turning points is fractions. It's just that as you substitute back in, particularly if you've got, x squared minus 3x plus 2 or something, when you actually, that's right, you'll end up with a fraction when you get the differential, you put it equal to 0, you're going to end up with a fraction that you have to substitute back in. I probably need to write that on the board to make sure I'm saying that the right way. But you end up having to substitute fractions back into the x squared minus 3x plus 2 thing in order to get the value of y. And that's what the kids find hard. So the kids in Year 7 sort of need to know that 80% of kids currently in Australia do a maths in post-compulsory, nearly all of which involve some fractions. So the Year 7 kids need to know they can't get out of this. And in the new national curriculum, the intention is to increase that 80%. Did I hear them say that they're going to increase the leaving age to 17? No, to 17 I heard them say that they're going to talk about changing that. And so what you mean is that those kids in Year 7 that are struggling to learn fractions have got 4 more years of it to do that. Now you're probably going to be good guesses at this. In the 2007 Victorian Year 9 AIM assessment, there was a question just like that compost one we looked at. George eats a third of a pizza, Jared eats a quarter of a pizza. How much is left for Loretta? It was a right-in answer, and 28% of Victorian kids could do it. Is all. In Year 9. I don't know if you can see this. I saw some research where it was written out properly, A over 5 plus A over 10, that they'd asked Year 8 and 9 students, and 80% of Year 8 and 9 students said the answer is 2A on 15. So we've got a problem with fractions. Clearly we're not, across the state, we're not teaching it well. Okay, why would we learn fractions? Well, to some extent I'm going to talk about it because you need to talk about it to kids. What's the chance the first 4 numbers drawn in the $90 million draw will all be odd? Well, the answer is a half times a half times a half times a half, 1/16. Now, that's much easier to understand than 0.0625 is the probability. So 1/16 is much easier to understand what the chance is. And so fractions are therefore important in that. I travel up a hill at 10 kilometre hill at 20 kilometres per hour and down the hill at 40 kilometres per hour. What's my average speed? Now, it's not 30. It's a fractions question. You can only do it by fractions. Kyle can paint a house in 5 days and Jackie can paint a house in 10 days. How long would it take to paint a house if they worked together? The only way you can do that question is by fractions. You can't do it by decimals. Or it's really completely counterintuitive to do it by decimals. It's a fractions question. And so we've got to understand that there are some things that only fractions can be used for. Height of water over sandbank is h equals 2 sine pi t on 6 plus 9. When can the oil turn? It's a fractions question. Now what do you see as the key issues in teaching fractions in grades 6 to 8?